Hello guys, welcome to my channel Astro'way. So, 2 days ago, I got a demand to make a detailed video on Pulsar by my viewers, and as I respect my viewers very much so I just started doing work on this video, and here it is. A very detailed video on Pulsar. In this video you will get almost all the information about Pulsar, and I promise that after watching this video you will have more knowledge about Pulsar than anyone else. So without wasting any time, let's start with our topic. Pulsars. Pulsars are spherical compact objects whose dimensions do not extend beyond the boundary of a large city. It is surprising that with such a volume they are massively larger than the Sun. They are used to study the extreme states of matter, the detection of planets outside our system, and the measurement of cosmic distances. In addition, they help to find gravitational waves pointing to energy events, such as collisions of supermassive black holes. First discovered in 1967, what is a pulsar? If you look out for a pulsar in the sky, it seems like an ordinary twinkling star, following a certain rhythm. In fact, their light does not flicker and does not pulsate, and they do not protrude as stars. The pulsar produces two persistent narrow light beams in opposite directions. The flicker effect is created because they rotate, beacon principle. At this point, the beam hits the Earth and then turns again. Why is this happening? The fact is that the pulsar is light beam, usually does not coincide with its axis of rotation. If blinking is created by rotation, then the speed of the pulses reflects the one with which the pulsar is rotating. A total of 2,000 pulsars were found, most of which make 1 revolution per second. But there are about 200 objects that manage to make hundreds of turns in the same time. The fastest are called millisecond, because their number of revolutions per second equals 700. The diameter of pulsars in the universe reaches 20 to 24 kilometers, and the mass is twice the solar one. For you to understand, a piece of such an object the size of a sugar cube will weigh 1 billion ton. That is, you have something weighing Everest in your hand. The truth is, there is an even denser object, a black hole. The most massive reaches 2.04 solar masses. Pulsars have a strong magnetic field, which is 100 million to 1 quadrillion times stronger than the Earth. In order for a neutron star to emit light like a pulsar, it must have the correct ratio of magnetic field strength and rotation frequency. It happens that the beam of radio waves may not pass through the field of view of the ground-based telescope and remain invisible. Why do pulsars spin? Slowness for a pulsar, 1 rotation per second. The fastest accelerates to hundreds of revolutions per second and are called millisecond. The rotation process occurs because the stars from which they formed also rotated. But to get to that speed, you need an additional source. Researchers believe that millisecond pulsars were formed by stealing energy from a neighbor. You may notice the presence of foreign matter, which increases the speed of rotation. And this is not very good for an injured companion who can one day be completely absorbed by the pulsar. Such systems are called black widows, in honor of the dangerous kind of spider. Pulsars are capable of emitting light at several wavelengths, from radio to gamma rays. But how do they do it? Scientists cannot yet find the exact answer. It is believed that a separate mechanism is responsible for each wavelength. Lighthouse beams are composed of radio waves. They differ in brightness and narrowness and resemble coherent light, where particles form a focused beam. The faster the rotation, the weaker the magnetic field, but the rotational speed is enough for them to emit the same bright rays as the slow ones. During rotation, a magnetic field creates an electric field that is capable of bringing charged particles to a mobile state, electric current. The area above the surface where the magnetic field dominates is called the magnetosphere. Here, charged particles are accelerated to incredibly high speeds due to a strong electric field. With each acceleration, they emit light. It is displayed in the optical and X-ray range. What about gamma rays? Research suggests that their source should be sought elsewhere near the pulsar, and they will resemble a fan. Search for pulsars. Radio telescopes remain the main method for searching pulsars in space. They are small and weak compared with other objects, so you have to scan the entire sky, and gradually these objects fall into the lens. Most were found with the help of the Parkes Observatory in Australia. A lot of new data will be available from the Antenna Array per Quadrant Kilometer, SKA, starting in 2018. In 2008, the GLAST telescope was launched, which found 2050 gamma-emitting pulsars, among which 93 were millisecond. This telescope is incredibly useful, as it scans the entire sky, while others emit only small areas along the plane of the Milky Way. Finding different wavelengths can be a problem. The fact that the radio waves are incredibly powerful, but they can simply not get into the lens of the telescope. But gamma radiation spreads through most of the sky, but is inferior in brightness. Now scientists are aware of the existence of 2,300 pulsars found by radio waves and 160 through gamma rays. There are also 240 millisecond pulsars, of which 60 produce gamma radiation. Using pulsars. Pulsars are not just amazing space objects, but also useful tools. The emitted light can tell a lot about internal processes. That is, researchers are able to understand the physics of neutron stars. In these objects so high pressure that the behavior of matter is different from the usual. The strange filling of neutron stars is called nuclear paste. Pulsars bring many benefits due to the accuracy of the pulses. Scientists know specific objects and perceive them as cosmic clocks. This is how assumptions about the presence of other planets began to appear. In fact, the first extrasolar planet found revolved around a pulsar. Do not forget that the pulsars during the flashing continue to move, which means that you can use them to measure cosmic distances. They also participated in testing Einstein's theory of relativity, like moments of gravity, but the regularity of the pulsation can be broken by gravitational waves. This was noticed in February 2016. Pulsar cemeteries. Gradually, all pulsars slow down. The radiation is powered by a magnetic field created by rotation. As a result, it also loses its power and stops sending beams. Scientists have put a special line in front of radio waves. As soon as the pulsar falls below, it is written off in the pulsar cemetery. If the pulsar was formed from the remnants of a supernova, then it possesses a huge energy reserve and fast rotation speed. Examples include the young object PSRB05 31+21. In this phase, it can stay for several 100,000 years, after which it will begin to lose speed. Middle-aged pulsars make up the majority of the population and produce only radio waves. However, a pulsar can prolong its life if there is a satellite nearby. Then he will pull out his material and increase the speed of rotation. Such changes can occur at any time, so the pulsar is able to revive. Such a contact is called a low-mass X-ray binary system. The oldest pulsars are millisecond. Some reach the age of billions of years. Neutron stars. Neutron stars are rather mysterious objects, 1.4 times the solar mass. They are born after the explosion of larger stars. Let us learn these formations closer. When a star explodes, 4 to 8 times more massive than the Sun, the core remains with a high density, continuing to collapse. Gravity puts so much pressure on the material that it makes protons and electrons merge to appear as neutrons. This is how a high-density neutron star is born. These massive objects can reach only 20 kilometers in diameter. To make you aware of the density, just one spoonful of material from a neutron star will weigh 1 billion tons. Gravity on such an object is 2 billion times stronger than the Earth, and there is enough power for gravitational lensing, which allows scientists to examine the back part of a star. The impulse from the explosion leaves an impulse that causes the neutron star to spin, reaching several revolutions per second, although they can accelerate to 43,000 times per minute. When a neutron star is part of a binary system where a supernova exploded, the picture looks even more impressive. If the second star is inferior in massiveness to the Sun, then it pulls the mass of the companion into the Roche lobe. This is a spherical cloud of matter that turns around a neutron star. If the satellite was 10 times the solar mass, then the mass transfer is also tuned, but not so stable. The material flows along the magnetic poles, heats up, and X-ray pulsations are created. By 2010, 1,800 pulsars were detected using radio detection and 70 through gamma rays. Some instances even noticed planets. So, hope you liked the video. I want to do very hard work to make every video, so please like the video and subscribe my channel. If you like the video, and if you have any other topic related to space, then comment boxes for there for you. You can comment and tell me, and I will make a video on it. So that's all for today. So, never die your interest in space. Always learn new things about space. We will meet again in the next video, but for now, be wise.